Hi everyone. So this is the problem. This is the today's daily practice problem, which is finding three-digit even numbers. So the problem goes like you are given an integer array digits where each element is a digit. The array may contain duplicates. You need to find all unique integers that follow the given requirements. The integer consists of concatenation of three elements from digits in any arbitrary order. So basically, the order of the elements in the value that we need to create is not mattering. And the second condition is the integer does not have leading zeros. So yes, so it simply means like it shouldn't be like 0, 1, 2 or 0, 2, 3. The third condition is the integer is even. So basically, these are the three requirements which need to be fulfilled. Only then we can consider that value as a valid value for the output array. So here we have an example like if the digits array is 1, 2, 3, the possible integers that we could create are 1, 3, 2 and 3, 1, 2, which are following the requirements. So here is an example. So here is a digits array like 2, 1, 3, 0. So we can see that all the digits that have been created are following these three requirements, which are like the digit must be even, and it shouldn't be having leading zeros, and the integers must be even. So the simple idea of brute force comes into our mind, like we will basically create three for loops that will be iterating over the digits array, and if the numbers are following the requirements that is given in the question, only then we will put that particular number into a result array and we'll return the result array. So here I'll be writing the code and I'll be explaining the logic. So this is the first loop, find range for Jane range then of array. So basically, I'm traversing over all the elements of the array right from the start. So yes, so now what are the conditions? So the first condition should be that we are not inserting the same element. Like for example, if I and j both are at 2, so we'll not be inserting 2 because it will be by that logic it will be meaning that we'll be we'll be considering the same digit two times. So we need to ensure that we aren't considering this single digit multiple times. So if I is same as j or I is same as k or j is same as k. In all these conditions, we'll be continuing the for loop. Yes. So now, in one more condition, we'll be continuing our loop. Like if the first digit is 0, which is the second condition that it shouldn't be having leading zeros. So in that condition also we'll be continuing our loop. So now what will be the number that we'll be getting? It will be r of I into 100 plus r of j into 10 plus r of k. Right. Now we'll check whether if x is an odd number, then we'll continue as we only need to consider even numbers, right? So then we will append into it x, right? So I forgot to create the result array. So yes. So one more condition that we need to ensure is we need not insert duplicate numbers. So by this brute force logic, there will be certain cases where we will be getting duplicate arrays. So to ensure that uh, make our we need to make a hash set, and in that hash set only we need to insert values so as to ensure that no duplicate values are entered into our list. Yes. So in result we'll be adding the number that we have obtained, that is following those three requirements that are asked in the question, right? So we'll finally return the result array, and we need to sort it also. So let's check the output of this. So we're getting an error. Yes. So here I've used and instead I need to use or. Okay. Now let's check the output. So it's passing the given test cases. Now let's submit it. So yes, this is an accepted solution, but as you can see, it's taking a lot of time, more than 3000 milliseconds, and we need to basically optimize this. So we can see what is the time complexity of this solution. So we are using three for loops. So the time complexity for this will be O of n cube, and here we are sorting the arrays. So n log n. So the overall complexity will be n cube plus n log n, right? Uh, okay, so now we need to optimize this. So to optimize this, one approach that you can think of is basically, if you observe this, that we are basically creating three-digit numbers, right? So all three-digit numbers that possibly exist are lying between 100 and 999. So based on that pattern, we can see that all the numbers that we need to insert into the array could be uh, uh, greater than or equal to 100 and less than or equal to 999. So so we could solve this question like, if we make a map. So basically I'll be writing the code and I'll be explaining the logic. So let's create a map which will be a counter of the R array. Then we'll create a result array in which we'll be storing the values that we obtain, right? So right, so here is the for loop. Here is the first for loop. So basically we'll be traversing. So first I'll write it, right? For in range, uh, right. So all the possible numbers uh, are lying between 100 and 1000, and I am traversing with a gap of 2 because we only need to consider even numbers, right? The integer should be even. So if we go about like this, then I'm creating a temporary map here, temporary hash map, right? A temporary hash map would be a counter. So like I'm making a string of the number that we're considering. So our temporary hash map will be a counter of uh, this string number, right? So if like the number would be 100, so our map will be like one. So this will be a string. One will be one, then two, then zero will be having two, right? So this is a counter like this, right? So now we'll be comparing the values, right? So like first number could be key in the temporary hash map. So if basically in the temporary hash map, the value of k is greater than in the actual hash map, in the actual map that we have created here, right? So the int form of that k, right? Because k is a string, because we had converted the number into a string format. So if it will be greater, so it yeah, clearly means that we are not having those number of digits that we are considering here. So basically means the number like we are considering 100, right? So 100 could not be created from this digits array. So this is what this logic exactly explains, right? So I'll be creating a flag variable here, f, which will be true initially, and if this condition arises, we'll be setting the value of flag as false. Now we'll check if f is correct. Then inside res we'll be appending the value that we had that we'll be obtaining, right? We'll be appending I value into the res array. So finally, we'll be returning the res array, and also we need not need to sort this because it is already in the sorted. It will be getting appended in sorted pattern only. So now if we check, so it is getting accepted on the test cases. So it is getting accepted, and it is its runtime is 15 millisecond, which is much better than the earlier solution, which was more than 3000 millisecond. So now if we try to check the time complexity here. So the time complexity here is we are traversing from 100 to 1000, 100 to 1000. So basically the length of the for loop is fixed, so we can consider it as O of 1, because because however large the array is, we are having a fixed number of for loops. So thus this is the final solution. Thank you.